Okay, let me jump into SpaceClaim now. So here's the SpaceClaim environment. I mentioned that we have built this software around simplicity so that anybody can use it. The way we've done that is through the user interface. I'm highlighting the four main tools that you use in SpaceClaim to do the majority of your work. So we've built everything around these. If you understand these tools, you generally understand SpaceClaim and how to get most of your workflows done. Anybody can understand these tools and the variations of it, so it is hands down an easy tool to use. Let me start off by talking about creating a model from the ground up. Common task people need to do, maybe for you're sitting around a room and you want to mock something up on the screen or send a model over to someone, or you have a simplified representation of a model that you want to run an analysis on. Well, we're not primarily a sketch-based tool, but I'm going to start with a sketch, get me going in the right direction, but I don't have to fully define it. I just have a line, that's it. Simple line, I don't care how long it is, where it is in space. The first of my major tools is called Pull. This is your primary creation and editing tool. I take a line, pull it into a surface. From there, I can transform the surface into a solid body. So that's a fast way to get something on the screen. Any face or faces that I pull on will offset, and this thing gets bigger and smaller. Now, I've been pulling on this thing left and right, up and down. I have no idea how big it is. But at any time, I can get precision, put precision into the model wherever I want, just by putting something like a ruler dimension. So as I create the model at the beginning, as I'm going along, or at the end, I can always dictate geometry. I can dictate dimensions and say that's needs to be 1.5 inches thick. Now this pull tool also works with edges. When I pull on an edge, the default behavior is to do something very common that people need. It's we put a round on the model, or I click a button and turn it into a chamfer at any time. Ease of use. You pull on an edge, it does that. Common tasks. You know, I want to get rid of that. I put it on the screen. I'm going to use a common Windows shortcut like undo just to get back to where I was with a box. So those Windows shortcuts, and you're going to hear me drill that home, those work wonderfully in SpaceClaim, and I'll show a few more in just a second. But I want to add some more things to this model. You know, I don't have to mess around with sketches anymore if I don't want to. I've got data around me that I can utilize, like edges. And so SpaceClaim is now intuitive. When I have a new region to play with and I pull on it, it knows whether or not to add or remove material just based on how I interact with the geometry, which direction in which I pull. You know, I can add some more features like rounds to the mix to make this more aesthetically pleasing. But I want to add something else. I mean, I'm going to use those Windows shortcuts again and copy and paste a surface or a face, and I end up with a surface. Okay, so there's my surface body I just copied and pasted. This is completely independent from the model. That means I could move it around with this second major tool, Move. This does translations in the 3 degrees of freedom or rotational freedom. So I can do anything I want. You know, as I said, I want to add more features to the mix and modify this thing further. You know, I'll actually move it just a little bit over to the left and start to pull on this. So I have what we might call a multi-body environment. There's two solids here. But I might say it's time to join these two together. I want to loft them together and have a nice smooth transition. Well, SpaceClaim, just by pulling between two faces, it knows I'm trying to make a loft, and it automatically makes it for me. It guesses that's what I'm trying to do, makes the loft, and I can just solidify it from there. Now, here's the kind of power you have in the way of editing a model in SpaceClaim, regardless of whether or not you created it in SpaceClaim. I'm going to say, let's just chop this thing up. The fourth major tool I have is called Combine. Now, the name's a little misleading, but it stands for combination. It merges but also cuts bodies. And I've said, let's cut that body right along that reference plane I inserted. So I've just sliced it in half and move it apart, and I'm free to do anything I want. Now, here's the power of the tool with a term I like to use called 3D plagiarizing. I'm going to open up a brand new file, and it's called Plate. Let's just open it up in SpaceClaim. And it consists of just a plate with a couple of holes in it. You know, I really like this design or the aspects of it, and I want to sort of merge it into the other one. So I can do that with SpaceClaim. I don't have to jump through hoops. The way I'm going to do it is the Windows shortcuts, copy and paste. You guys probably all use something like Microsoft Word, and you copy and paste things all the time. So I'll just paste this thing into the document. Now let me change the color so it's a little easier to see things. Change it to orange, and from here, use my move tool and shift that thing into the position that I want. Now you'll have to extrapolate a little bit. This thing isn't exactly the right size, and it's not in the right location. But you can imagine if I've got a couple of designs and I need to somehow join them together, I'm free to do that with this tool. I mean, think of this as like Play-Doh on the screen. It's just geometry to us, so we let you modify things however you want. You know, say I want to join those two together, make a nice smooth transition. I use the pull tool and blend right between them. So there's two bodies on the screen. When I do the last merge, I'm back to one body. I mean, this part is drastically different from what I started with, right? And I've used only 3 tools to do it: pull, move, and combine. I haven't even shown you fill yet, but I'll show you that in a moment. So the point of this one was to just give you a flavor, an idea of the different things that you can do in SpaceClaim and introduce you to the workflows. Now let me transition to another model, and we'll talk more about editing files. This is a ACES file I'm going to bring in. That's a neutral file format. It's actually the kernel that SpaceClaim runs on. But let me show you the different file types that SpaceClaim will open. I'm zooming in right now so you can see them all. Basically all the major players of CAD, they're up here. You can open up these files, all these files in SpaceClaim, and edit them as if you created them originally in SpaceClaim. You have that kind of flexibility and that power. Now here's a model, and whatever you're trying to do, if you need to modify this for analysis, or if you just need to simplify it and make changes, you can do it in SpaceClaim. Let me show you how. There is no structure tree if you're used to a feature-based CAD system. I don't have any features and sketches to go edit. So that's a problem, right? Not in this tool, because I have this third major tool is called fill. I mean, if my pull tool creates data, geometry, my fill tool is what gets rid of it. I select things I don't want and just fill it in. It's sort of that magic eraser button. So I have a hole over here with all the teeth, the internal teeth. You know, if I grab that entire thing and say fill, it just goes away. I delete all that at once. You know, I'm going to undo. Because maybe I want all the teeth, or I'm sorry, I don't want the teeth, but I do want the hole to be present. You know, there's half a dozen ways to get rid of that hole. I could fill in the teeth, or I could say, let's just pull on that top face and pull on it till it's infinitely small or 0, and I'm left with a diameter with which I can pull on. You know, I don't know who created this file. I don't know why, when, where, their design intent, any of that, but it doesn't matter. Because it's just 3D data to us, we let you edit it. Now take rounds, for example. I know for a fact when analysts are working with a model, they do not want rounds because it adds to the complexity and degrees of freedom, much like raised text that I got rid of originally. So I use the fill tool. Fill it in and I get a sharp corner. Now, that's great in and of itself, but I have a lot of other rounds I may want to get rid of. Well, I could grab a chain at any time by double-clicking and say, let's fill those in. But, you know, there's still a lot more rounds in this model. Do I want to go through all of them individually and grab them? No, it's kind of a pain. So I needed a unique way to select them. And we have a tool called Power Select, which looks for similar geometry in the model. In this case, I can tell it, I want you to, SpaceClaim, to grab every round in the model that's equal to or smaller than the one I just selected. And there's different ways to search, but that's just it's a common one. Down at the bottom, it tells me, the bottom of the screen, it tells me I've got 82 faces selected, meaning 82 rounds selected. And that's all it does is a selection tool. But between that and the fill tool, I can wipe all those rounds out at once and drastically change what this model looks like. And I can keep going from there. There's what looks like a cam profile of this rounded, of this cylinder. Maybe I don't want that. So I take some faces, fill it in. I don't know how it was created, but you know, it doesn't matter to me because I can get rid of it. So say I want to simplify this further, right? There's a lot of these standoffs that go all the way around the model. You know, I want to get rid of them. I could use that Power Select tool and get everything that happens to be coincident to that face. It's another way to look for similar geometry. Grab another face, add as many to the mix as I want, and just pull on them until they're gone. Pull on them until they go up to another surface and are essentially consumed. But one of the first things I showed you was dimensional control, and I could certainly control the height of things with a dimension. You know, that looks like it's almost a quarter of an inch. I'll make it 150 thousandths or whatever value I want. But guess what? When I make it 0, they just go away. Those standoffs just go away, and it's as if they were never there. Now, this is actually my favorite tool in the software because of what it lets you do in so many short, just 2 button clicks. I click one face, and it's the split solid tool. It slices up the model along that face, divides it into multiple bodies, and it puts me in a mode of now deleting those extra bodies. So I had 4 bodies, now I'm down to 3, down to 2, and I keep clicking away, and I get rid of bodies as I click along. This model looks a heck of a lot different than it did when I started because I'm able to defeature and simplify things so easily. But, you know, if I need to add things to the model or modify it in any way, SpaceClaim lets me do that. This entire standoff, this entire bracket, I don't know what you would call it on the right side, 2 button clicks, split solid, and I've broken that up and can delete the whole thing. I mean, that's the kind of power that you have. There's more things I can do in the model, but the primary purpose of this was to show you some of the editing and defeaturing capabilities. All right, so let me go on to another one. This is a fun one to show. Some of you might be around the automotive industry, and so you're just used to automotive-like parts. And let's see, frame member, here we go. I've already converted this to a SpaceClaim document ahead of time, but it came to me as something else. Now, let's say that this file, this is just some kind of a primitive frame. You receive this nice clean model and you want to propose some changes to someone else. There's some kind of a design requirement and some sort of an interference, and you need to make a new concept. You just need to edit this thing, and you don't want to jump through hoops in how you do it. Use the tools in SpaceClaim to quickly and easily edit a model. So all I'm doing right now is making a couple of planes and spreading them apart, and I'm going to use these planes as a basis for how I want to slice up this model. So I use this combine tool and say I want to slice it up along these planes, and now this model consists of 3 bodies. So what are the things I can do with this? Well, in order to get rid of this interference, I might need to take the 2 ends that are highlighted right now and shift them apart. I could move those in a symmetric fashion, so it just saves me a step basically. Let's see here. So I move them in a symmetric fashion, you know, as far as I want, and again I can put precision in and say let's go exactly 0.35 inches, and then move them slightly this way, and that'll take care of the interference and where things now need to be situated. But I've got 3 solids. I need to join them together. So just as before, I could elect to just pull between them and get a brand new solid, get a brand new lofted section. SpaceClaim does it automatically for me, knows what I'm trying to do. This is basically a brand new model, but let's make some more changes to it. These holes. You know, maybe I want to copy this hole and have it traverse along, just have it go along this edge, right? I hold down the control key as I'm making a movement, and it makes a copy. I mean, that's a Windows shortcut. Everybody gets that and knows that. But I can actually copy it along this edge and have it go up this face. And so I know it's the same distance from that edge wherever I go. Oops. I'm going to undo that. It jumped on me a little bit. Let's put one right there. There we go. So I've got a couple new holes. And so, I mean, obviously this isn't detailed. Maybe this looks a little goofy how I have the holes, but I think you get the idea on the capabilities and the power you have for editing this model. If I want to throw some rounds on the top to smooth this thing out because somebody just plain old didn't do it right, or the intent isn't the way you want it, I could do that and pop some rounds in. You see all the 8 holes that are on the brackets on the side or on the top right by the ears I just put in? You know, maybe I want to change those. modify them. I don't want to select all 8 holes. Either there's too many of them or I'm lazy. So I'll use that power select tool and grab every hole that's the same size and then go make a modification to it. Pull on them, make them bigger or smaller. I could move them around. I could get rid of them if I wanted to. In fact, let's go get rid of, I'll just say one of those holes for now, just so there is something that's definitely gone from the original. I'll fill it in. Okay, so I've made a bunch of changes. This is my new concept. I say, hey, I want to run this by someone and see what they think. How do you do that? How do you do that in a 3D fashion? Well, what I would first do is save this off as a new version. So it's related to the original. It's called framemember.2. Okay, so you got 2 files, framemember and framemember.2. Comparing the two, as far as comparing the two, we give you a tool called 3D Markup, and it lets you compare things in a familiar, easy to understand 3D fashion. Now let me go find where that original file is called framemember and insert that into the mix. Okay, so I got 2 files on top of each other. The original is somewhat transparent, and the new one in the lower left is the one that's colored. How do you show changes? Well, dimensions is really the best way to show changes between things. So I could put some dimensions in and show, in this case, maybe what the overall dimension is. It tells me it's about 9 1/4, and it was 7.3. So I get is/was dimensions, and I could put those anywhere in the model that I want. Putting in a new annotation plane, and I could tell what the distance of this offset is. It was 0, obviously. There was no offset. Now it's exactly 0.35 inches, 350 thousandths. All right. You know, sometimes dimensions don't always cut it, and you might need an annotation. I'm not sure what to type, what's relevant, so I'll just say annotation goes here, and I can point that. Anything I want, any sort of text you need to show or to put in there to convey what's changed, you can do that. However, is it always apparent everything that's changed through dimensions or annotations? Maybe, but pictures are worth 1,000 words. What we let you do is click a button and show all the changes in color. So every color on the screen means something unique. You know, a green is a brand new face. You'll see on the old model, there's something that's red, that hole. That tells you it's gone from one iteration to the next. Yellow, just a location change. Blue means something has changed along the face in one way or another. So they all mean something and tell you intelligently what's happened. So what you're looking at on the screen is a slide right now. And here's that slide. I could always add a new slide to the mix and show 2, 3, 4, as many iterations as I want and have as many slides as I want, as many different viewports to show what's actually happened on this model. And what do you do with slides? Well, you save them out as a PowerPoint document. So what you see on the screen right there in SpaceClaim gets saved out to a PowerPoint tool. So this is called 3D Markup. Great tool for communicating in 3D, whether within your company or outside, conveying all the changes in an easy-to-understand 3D fashion. Okay? So that's the next example I wanted to show you. Let's see what's next. There's a couple different directions I could go in. I'll show you one more model and give you a feel for how we might handle something like a plastic injection molded part. This is, let's see here. This is going to be a step file I bring in. I think it's called Base Design. That's great. You can just drag and drop files right into SpaceClaim and they open up. They open up right there. Step file, again, I can't stress the importance of it. I don't know how this model was created. This is just dumb 3D geometry to me, but I can go in and start making modifications anywhere I want, add some rounds to this. You know, maybe the point is I need to make this thing more manufacturable. Someone gave me a model that's close to being manufacturable, but it's just got to have changes on it so that there's the proper draft everywhere. Again, anything I need to modify in here, I can accomplish. If I need to change the actual distance of this opening, right? I go move some faces around. Now, I accidentally selected something wrong, but I could move this thing up and down. I probably need to get the face below it if I'm worried about the thickness of it. and sometimes I can't. So right there, I wasn't able to make a change. You know what I would just do though is probably fill in those faces and just get rid of them. I'll just undo it for a second and show I could move that thing up or down and change the depth of it. In fact, I might just try to move it right now while those rounds aren't there. I mean, rounds can be problematic anywhere. They're complicated, but we give you the tools to either undo what you've done or fill them in. There we go, and then go make those changes. So now I could just reinsert those rounds, or actually add draft to that face, to those vertical walls, and I'll show you that how to handle draft on the inside of this model. There's a ton of things I could do on this model, but I'm going to try to just keep it short and simple. How do you know if you need draft on something? How do you know if something is moldable? Well, we have a tool that lets you look for, it's a draft analysis, and it will show you what your draft actually looks like. Now I have it set to 0 degrees, so that's not relevant. So if I change the angle to 2, then every face that shows up in red, it does not have adequate draft. It doesn't meet that 2-degree requirement. You can see the perimeter, that ring around here that's red. So I need to take care of that, and then a bunch of things on the inside as well towards the center. So let's just take care of both of those, and I think I'll kind of wrap things up. All right, this perimeter, that ring doesn't have draft, so again, there's a lot of ways to remedy that, but I think the easiest way would just be to get rid of those faces and let the walls, the vertical walls, extend up. So I just fill in the faces. What's happened, excuse me, what's happened is that the vertical walls have just extended all the way up, and there's adequate draft everywhere. Now, something I'm not sure if I've shown you yet, I don't think I have, but this is extremely relevant in the way of modifying models, is that we let you slice a model in half and visualize it in a familiar cross-section mode. It's not good for just visualization, but you can actually fully edit a model in a cross-section mode. So pull, move, fill, and combine, those 4 main tools and everything else I've shown you, you can utilize those in a cross-section mode. So how would I do that? I've got things like draft that I need on those 8 vertical walls. You handle things like draft with the pull tool. I grab faces I want to draft with this and select a draft plane, and it tells me right there what the draft angle is. Excuse me just a second. All right, so it tells me what the draft angle is. From here, I could say, let's make this 1 degree of draft. 2 degrees. I can type in a value I want or just dynamically change it. Sometimes you may not be able to dynamically change things if your geometry is so complicated, but generally you can. So there's 3 degrees of draft I've just put on 8 faces with the pull tool. Notice I don't have a special draft tool. I just use pull to do most of my creation and editing functions. Now I could keep going from here and touch every face that may need draft and modify it, but hopefully you've seen by just all the examples that I'm doing how SpaceClaim is an enabling tool that lets you take in any 3D data and modify it how you need to. So I'm going to keep things a little short and stop there. I want to see if you guys have any questions for me. I think there's one that came in. Feel free to type them into the question box, and we'll go from there. Now, if we can't answer your questions, we'll for sure be following up with you guys to make sure you get them answered. One question that came in was regards to point cloud data and just data from a laser probe. What we will do is the format that we really need to get data in if it comes to scan data is a STL file. So if you have something that will turn your point cloud data into an STL file, that's really the way that you want to handle it. We'll take things like a text file of points and utilize those, but if you're talking about point cloud data, yeah, we really need a different format like an STL file. And to my understanding, there's a lot of programs that will do that, will convert point cloud to STL. So good question, though. There's a question about getting data from scanners and any plugins that we have. Not at the moment. I mean, this is really, I think there's other software that really concentrates on that. And again, we handle the editing of data once you have it in a 3D form, or if it's not in a 3D form for whatever reason, if it consists of surface bodies or something that came from elsewhere that's incomplete, you can convert it to 3D, but there's no plugins that I'm aware of. Can you make a model from a point cloud? Well, again, that was another question. We can't import point cloud data, but what we can do is, STL file is generally facets reference data. It's not a solid body. What we give you the capabilities to do is hang data off that STL to reference it and make, whether it's prismatic surfaces, which is most of the stuff I showed you today, or complex surfaces, NURB data. You can make, we do some great things with surfacing. You can make some complex surfaces in SpaceClaim and edit those to one extent or another. Tools like Pull may not be as relevant on a NURB surface that's extremely complex, because there's a million different things that could happen with the surface. So the software doesn't necessarily know what you're trying to do and won't make a guess right there. You have to use some other tools so as to control it. Can we import? Yeah, question about what we can import. STL files, yes, but if it's a solid file, if it's a solid body, whether it's SolidWorks, Unigraphics, Autodesk products, CATIA, what else am I missing? JT files. We will import those, and let you modify them. So there's a question about STL files. That might be one to follow up another time. Actually, I do have an STL file that I'll pull up right now and show you how that can be modified. Let me go find something. Just a second. Okay, so yeah, as I said before, STL files are just faceted data. They're not solid, so you have to use some kind of tools to recreate the geometry for you. Okay, let me get that on the screen. All right, so here's an STL file that I brought in. It comes in and it says mesh, so it's not a solid data. You can tell right away. If I show all the facets of the mesh, you can see just how complicated this thing really is. So the scan did not come in very clean, and this could be the result of any sort of scan, just bad data. So we let you actually recreate this. Now there's a bunch of things I could show you. Again, I'll just kind of keep it simple for now. How do you do it? Well, the trick is two things. When you take a cross-section of an STL, we will find out where the cross-section intersects the facets, and we'll actually let you fit a curve around it. We will draw a series of splines and arcs and lines that clearly fit where the facets intersect. Now, for me to recreate this, I really only need one half of it. I'm going to skip out on the left-hand side, right? That's not relevant for me because it's not complete, so I'll use just the right-hand side instead. So I just use a couple simple sketch tools to be able to get this in a useful state and get rid of everything on that one half. Now I have a closed loop set of sketches, or sketch entities, vectors, that turns into a surface. How do I recreate this thing? I use the pull tool and say I want to revolve it around an axis. Let me just zoom out for you and make a full revolution. And I've got that part recreated. There are some complex surfaces on this, but regardless if they're prismatic or complex, we will still create those. So if I change the color, you ought to be able to see the real part and the mesh side by side. Let's change that to, there we go. So you can see how closely they fit. I mean, it's basically right on. But it's only going to be as good as your scan data is. And I can get more and more precise if I use more cross-sections, whatever the case may be. It's just a function of how much effort you want to put into it, but we can recreate that data. So, okay, I think that's about it for questions. I'm going to go ahead and wrap it up there. And if you guys do have more questions, feel free to ask them. Get in touch with the folks at Laser Design, and they'll answer them as best they can. And talk to us if you have them, and we'll work with you guys in trying to show you the benefits of the software and how it fits into your workflows. So thank you very much for joining, everybody. I hope you have found it beneficial, and hope to be working with all of you in the future. Bye-bye.